Determine the domain and range of each function from its graph. When finding domain and range, remember that the domain is a set of x values that are allowed in the function. And generally what domain looks like is these x values fall between the left-hand endpoint and the right-hand endpoint. The range tells us the set of y values that we get as outputs. So the range will fall, these are the y values that fall somewhere between the lowest y value, the bottom y value, and the topmost y value. So applying that to problem A, we look at left and right first because we're trying to find the domain. The left-hand most point anywhere on this graph is right here at x equals -2. And the right-hand most x value is x equals +2. So if we follow this setup here, the domain runs from -2 to +2. Let's look at the range now. Remember, the range runs from the bottom to the top, the lowest y value anywhere to the highest. The lowest point anywhere on the graph is right here, and the y value here is y equals -1. The highest point anywhere on the graph is up here, and its y value is y equals +2. So the range will run from -1 to +2. So now we have the domain and range of the first graph. Applying that same process to the second problem, we look at the left and right first because we're trying to identify the domain. The left-hand most point anywhere on this graph is right here at x equals -2. However, there is no right-hand value because this arrow says that this continues right indefinitely. So when we first go to set this up, the domain runs from the left-hand most point to the right-hand most. I know that the left-hand most point is x equals -2. The right-hand most value, there isn't one. So we can write this as -2 is less than or equal to x, and we won't include an inequality on the right because there is no right-hand point. And then we can pretty this up by moving the x to the left-hand side of the equation. In that case, if -2 is the smaller of these two numbers, it's less than or equal to x, that means x must be the larger of these two numbers. So x is greater than or equal to -2. We can find the range in the same way. We look for the bottommost y value and the topmost. The bottommost y value, the lowest point anywhere on the graph, is right here at what looks like y equals -1. Now you may be tempted to say that this is the topmost y value at y equals 2, but this arrow says the graph continues up indefinitely, so this is not the top value anymore. In fact, because this goes up indefinitely, there is no top value. So if we were to set up the inequality like we did before, we know that our y values run from the bottom to the top. The bottommost y value is y equals -1, and there is no top y value. So that says that our range looks like -1 is less than or equal to y. And then just like before, we can reorganize this so the y comes first. If -1 is less than or equal to y, then y is greater than or equal to -1. So now we have the domain and the range for part B. Problem C, we can do the same way. For domain, we can look at the left and the right. So remember, the domain runs from the left to the right. To the left, this arrow indicates that the graph goes on indefinitely. So there is no left-hand endpoint. To the right, this arrow indicates that it continues indefinitely. So there is no right-hand endpoint either. So this says there are no restrictions at all on x. It can go indefinitely to the left and indefinitely to the right. And so we would say the domain is all real numbers. Or if you wanted to write this a little bit more compactly, we would say that the domain is R, all real numbers. Now let's look at the range. Remember, the range will run from the bottommost y value up to the topmost y value. The lowest y value anywhere in here is at this point at y equals -2. And this arrow at the top says the graph goes upward indefinitely, so there is no top y value. So the bottom is -2, and there is no top. So we can summarize that as -2 is less than or equal to y. And then just as we did before, we can reorder this by saying that y must be greater than or equal to -2. So our domain is all real numbers, and the range is y must be greater than or equal to -2. On part D, we do this the same way. So for our domain, we look left and right. On the left, this arrow indicates that this graph goes to the left indefinitely. And the same to the right. The arrow on the right-hand side says that there's no restriction on the right-hand side. So our domain is all real numbers. Now on to the range. The bottommost y value, it's not this point here because the graph continues down to the left. This downward arrow says there is no lowest endpoint. And this right-hand arrow, the arrow on the right that goes upward, says there's no highest point. Since there are no restrictions on either sides, we say the range is all real numbers. On to part E. For the domain, we look at left and right again. So the left-handmost point anywhere on this graph is right here at x equals -2. And this arrow to the right says there is no right-handmost x value. So that says x is greater than or equal to -2. For the range, we look at the bottom and the top like before. There is no bottom y value because this arrow says the graph continues downward indefinitely. But there is a top y value up here at what looks like y equals 1. So the range is that y is less than or equal to 1. Finally, on part F, we look at the domain. This is left and right. To the left, this arrow says the graph continues indefinitely. To the right, this arrow says the graph continues indefinitely in this direction also. So there are no restrictions, and so the domain is all real numbers. And the range, we look at the low point and the high point. These arrows say the graph continues indefinitely downward, so there is no bottom y value. The top y value could be either here or here, and those are both at approximately y equals 1. So that our range is that y must be less than or equal to 1.